Good afternoon, guys. So this video is going to be a little quicker than the last one because I'm going to be showing you some shortcuts for graphing today, and that shortcut is known as a function transformation. So we'll talk about what that means here in just a minute. And you know what time it is. Before we go any farther, we have to remember what our functions look like. Okay? So you've got linear. Could look like any of those. You've got quadratic. In quadratic, we call a parabola. Okay, that's the name of that shape. But remember, it just looks like a hill or a valley. You could have a square root graph. Looks like an arrow being shot off into the distance. You could have a cubic function. And I should have drawn this last time, but cubics can go up or down. Okay? You could have a cube root function. That's your snakes. And they can also go up or down. And then the last one is absolute value. So those are our functions that we could potentially see today. Okay? So, what do I mean when I say function transformation? Here's what I mean. Look at that little equation on top, y equals x squared. That is a quadratic, and that is the simplest quadratic I could ever have, because there are no numbers in that equation. What does it mean if you have an equation with no numbers in it? It means that graph, if I were to graph this, that parabola would have its vertex at 0, 0. Okay? Well, why is that important? Because not all graphs are at 0, 0 on a graph, right? We know that something must be happening because sometimes we see parabolas and they are over at the point 4, 2. So how does that happen? Well, it happens when I start adding positives and negatives and numbers into my equation. So the equation that you see on the bottom is also a quadratic. Okay, this one right here, this big long one, it's also a quadratic because it's got an exponent of 2. Okay, but AH and K stand for different numbers that I could have plugged into this equation. So let's break down this equation. The first thing I check is I look at the plus minus out front. Okay, if that is a positive, then that parabola will point up. If it's negative, that parabola will point down. And if it points down, we call that a reflection. Okay? So that's what the symbol out front tells me. If I have a positive number, I know that parabola is going up. If it's negative, I know it's pointing down. What does A stand for? A stands for any number that I could have put out in front of the parentheses. Okay? Well, if A happens to be bigger than 1, so it's like a 2 or a 3 or a 4, then what I've done is I've taken that parabola and I've stretched it so it gets tall really fast. But if I have a smaller number than 1, like 1/2 or 0.4, or 1/4, okay, that would be a shrink. So the number out front tells me stretch or shrink. All right, the last two things I got to talk about are H and K. Notice that H is in parentheses with X. Well, X runs left and right on a graph. So H, or whatever number is in parentheses, tells me how far left or right this parabola has moved. And something special about H, and it's the only one that is this way, it will swap signs. Meaning, if you see a -3 in parentheses, what actually happened is that you actually went right 3. And that's just because of this negative right here in the equation. Okay? Lastly, what about K? K is the number out here by itself. What it tells me is how far up or down I went. So if it was like a +3 outside, I would know that I went up 3. If it's a -3 outside, I know I went down 3. Okay? So those are all examples of some different transformations that I could have. So let's put that into practice. Which graph matches this equation? We'll start breaking it down. The first thing that I check is the symbol out front. There's a negative. What does that negative tell me? It tells me this graph is going to point down. It's been reflected. So it, therefore, can't be the first one. It's got to be one of the last 3. Okay? If I had a number in front of parentheses, then I would take a look at that. Technically, there's a 1 there that's understood, but that really doesn't tell me anything. So I keep going. What's the next thing I see in this equation? I see a -3 in parentheses. Okay? Normally, I would think, well, that means left 3. But I know that numbers in parentheses swap signs. So what this actually means is that it went right 3. Okay? Now check the last number, +2. What does the number outside parentheses tells me? It tells me if I went up or down. Well, since this 2 is positive, that means I went up 2. So instead of having a vertex at 0, 0, I should be looking for a graph that has a vertex at the point 3, 2. So let's check this. If I started at 0, 0 right here, and I went right 3 and up 2, do I end up at the vertex of this parabola? Yes, I do. So this one right here is my answer. What about the other ones? Well, to get to the vertex on option 3, I'd have to go left 3 and up 2. Well, that's not right. And on the last option, I do go right 3 to get to the vertex, but I have to go down 2, and that's not right either. So option B, the second choice there, is the right answer. So what's happened here is I have this equation that they gave me. It's in what's called vertex form, meaning if I look at the equation and I look at the numbers, I can tell you what the vertex is without actually having to do any math. I can say, well, I know the -3 swap signs, the 2 stays the same. So my new vertex is going to be +3, +2. But my transformations are, it's been reflected, I went right 3 and up 2. Okay? Next example, this one's going to be a square root function, but it works the same way. It says the graph of h of x equals square root of x. So something I want to mention again. Okay? This graph would be starting at 0, 0 because there's no numbers in it. That is what's called my parent function because I haven't put any numbers in it. But it says it's been shifted to this new equation right here. So what I want to know is what transformations occurred. So let's break it down step by step. I see a negative out front. That negative tells me this graph is going to be upside down, and we call it a reflection when it's upside down. And actually what we say is we say a reflection across the x-axis, but that's really wrong. Or excuse me, not wrong. That's really long. So if you just tell me reflection, I know what that means. This time I have a number out front. I have a 2. Well, that 2 is bigger than 1. What I'm doing is I'm taking that square root and multiplying it by 2, so it's getting bigger. So that means I have a stretch as well. A stretch of 2. Now I look at the last 2 numbers. So take the 7 here. That's a +7. The 7 is inside the square root with x. Okay? Well, that means it's telling me whether or not I'm going left or right. Well, just like when that last number was in parentheses, it swapped signs, that 7 swaps signs. So normally when I see a +7, I think, oh, well, I went right 7. What's actually happening is that I went left 7. Okay, so remember, again, I can't reiterate this enough. If there's a number and it's inside parentheses, if it's inside a square root, if it's inside absolute value bars, anything where it's inside with x, it swaps signs. My last number now is a -1. Well, that tells me that I went down 1. There's my 4 transformations. Okay, I started out with this top equation, h of x, I started out with something that was at 0, 0. Okay, and it hadn't been stretched, it hadn't been flipped upside down, nothing. It was just a regular old square root graph. Now it's been flipped upside down, it's been stretched by 2, I've shifted it to the left 7, and it's gone down 1. So that graph's going to look very different than the one that I started with. Okay? Alright, next one. So similar question. What steps transform the graph of, this is y equals the cube root of x, to the graph of y equals the cube root of x plus 8. Okay, so again, go step by step. We started with something that was at 0, 0. We're no longer at 0, 0 in the second one, because I now have a +8 in that equation. Okay, so did I reflect this graph upside down? No, because there's not a negative out front. Did I stretch it? No, because there's not a number out front. Did I move it left or right? No, because there's not a number inside that cube root with x. The only thing I have to worry about is that plus 8. It's sitting outside by itself at the end. So what is that plus 8 telling me? It's telling me that I went up 8. And that's the only thing I did. If there was a number inside the cube root with x, then I would have also gone left or right. But because the only thing I changed was putting a plus 8 on the end, the only thing I did was go up 8. Okay? Last example here says graph the following function. R of x equals the negative cube root of x plus 1. So I'm just going to draw myself a little picture just because I want to remember that that's what a cube root normally looks like. Okay? Now, here's the thing. In the last lecture, we talked about the fact that you can plug in numbers into equations and graph this, and you absolutely can do that. But if you don't want to do that because it takes a while, here's your shortcut. If all I had was this, if it just said the cube root of x, then that graph, that squiggle or that snake, would be centered at 0, 0, and that squiggle or that snake would go out from 0, 0. But there's some other stuff going on here. The first thing I notice is the negative out front. Well, that negative tells me my snake here is going to be upside down. So because of the negative, it's now going to be going like that. Okay, I've reflected it. What does the plus 1 do? Well, the plus 1 is inside with x, which means I'm either moving this thing left or right. Well, remember, if it's inside with x, it swaps signs. So what am I actually doing? I'm going left 1. So instead of being centered at 0, 0, I'd be going left 1 right here, and my squiggle is going to be centered around that point. So let me recap that. Normally, we have a snake that's centered at 0, 0, okay? If I've got a cube root function with no numbers in it. Because I put a plus 1 in there, I had to move it left 1. Because of the negative, that snake or that squiggle is now going down. That's all I would have to do in a multiple choice question. I'd have to find the squiggle that was centered at negative 1, 0, and that was going down. That's it. I wouldn't have to plug in all those points to figure out which one was right. Okay? So that is the end of our discussion of function transformations. Please, please, please let me know if you have questions.